Hello friends, I am Dr. Sanjay Gaikwad, Associate Professor in Chemistry at BGS College, Wabuli, Pune. Today we are talking about the ionic equilibria is a basic fundamental topic. Under this topic, we are going to discuss on electrolyte, degree of ionization, ionic product of water, ionization of weak acid and bases, common ion effect, salt hydrolysis, Henderson equation, buffer solution and the buffer capacity. Now in school level we did the experiment. This is a sugar solution and in another beaker we are taking the salt solution and two electrodes are kept in the solution and it is connected with the bulb through the battery. Now it is observed that in case of the sugar solution bulb is not glown and in case of the salt solution bulb is glown. Now this is because the salt solution the salt is completely ionized and it conducts the electricity and therefore it becomes a closed circuit and therefore bulb is glown. Now in this way some compounds are we are saying that it is an electrolyte. Now some compound electrolyte when dissolved in water it completely ionizes and it gives the formation of positive and negative ions. Now the electrolytes are classified as a strong electrolyte, moderate electrolyte and weak electrolyte. Now in case of the strong electrolyte, the ions compounds when dissolved in water they completely ionize. For example, in case of NaOH, HCl, H2SO4, KCl, NaCl. Now when they dissolve in water they completely ionize. Therefore these type of electrolytes are called as a strong electrolyte. Some electrolytes like copper sulfate, silver nitrate and barium chloride they moderately dissociate and therefore these type of electrolytes are called as moderate electrolyte. And when such a type of compounds or electrolyte like silver chloride, acetic acid, silver iodide, now these type of electrolyte when dissolved in water, then what happen? They very small amount of the compound get ionized, that is a very partially dissociate, and these type of electrolytes are called as weak electrolyte. And some electrolyte like sugar molecules, they when dissolved in water they dissolve, but the ions are not conducted, the ions are not formed, and therefore these are called as the non-electrolyte. Now these electrolytes when dissociate into the water, how much dissociated it can be calculated on the basis of in terms of the degree of dissociation. It is denoted by alpha. For example, with respect to the Oswald dilution law, consider the Ba is the electrolyte, and when this Ba electrolyte when dissociate into the B plus and A plus minus ion, then we can observe with respect to the we are studied with respect to the equilibrium constant. Then it is observed that the equilibrium constant K is equal to concentration of B plus into concentration of A minus divided by concentration of Pa. Now this concentration, from this ratio we can find out the equilibrium constant. Now equilibrium constant in terms of the when how much it is dissociated, on this basis suppose alpha is the dissociation takes place, then alpha is the concentration of B plus and alpha is the concentration of A minus, and this alpha concentration is reduced from the initial concentration. Now from this equilibrium constant we can find out the value of K is equal to C alpha square upon 1 minus alpha, and where alpha is the degree of dissociation. Now this degree of dissociation can be estimated, can be measured with the help of conductometer in terms of the value of del, that is the equivalent conductance, and del 0 is the equivalent conductance at infinite dilution. Therefore alpha is equal to del upon del 0. From this equation we can measure the alpha from the conductometer. Now in case of the weak acid, suppose acetic acid dissociate into the acetate ion plus hydrogen ion. Now from that equilibrium constant for the acid Ka is in terms of this Ka can be calculated the concentration of acetate ion into concentration of hydrogen ion divided by concentration of acetic acid. Now this after the dissociation degree of dissociation we can measure the ionic product of water. Now we know that the water dissociate into the H plus and OH minus ion. Water is not that much, we are saying that the H2O, but it is a hydrogen ion combined with the H2O, and we observe that hydronium ion concentration and OH minus ions they are present in the water. Now this water when dissociate, we are saying that it is a Kw equilibrium constant for water is the concentration of hydrogen ion into the concentration of OH ion or activity of hydrogen and OH minus ion. Now degree of ionization for alpha is for the water is 1.90 into 10 raised to minus 9, and the value of del, it is observed that at 25 degrees Celsius is 1.045 into 10 raised to minus 6. Now from these two values we can find out the specific conductance of the water at 25 degrees Celsius is 5.8 into 10 raised to minus 7 moles per centimeter. Now for water, the concentration of hydrogen ion and concentration of OH ion, they are very equal, and from that we can find out the concentration of hydrogen ion is nearly equal to the 1.0546 into 10 raised to minus 7, and this is the concentration of hydrogen ion and OH ion. The ionic product of water from these two, it is observed that 1.112 into 10 raised to minus 14. This is the concentration of the this is the ionic product of the water. Now when water dissociate certain molecules, for example weak acid or weak base, when dissociate into the its ions, the equilibrium constant for the acetic weak acid or equilibrium constant of the weak base can be find out with the help of K is equal to H ion concentration into A minus ion concentration divided by concentration of HA. This is the equilibrium constant of acid. This is the equilibrium constant of the base. Now the value of Ka is directly proportional to the concentration of hydrogen ion, and value of Kb is directly proportional to the concentration of OH ion. Therefore we are saying that the higher the value of Ka, stronger will be the acid, and higher the value of Kb, the stronger will be the base. Now from the value of Ka and Kb, the new term, that is the pH, that is the potence of the hydrogen ion or power of the hydrogen ion, can be calculated. We know that the equilibrium constant for the water, the product concentration is in terms of the 10 raised to minus 14, and therefore pKw is 14, and from that 14 the value of pH is equal to minus log of H ion concentration minus and pOH is the minus log of OH ion concentration. From that way we can understand that the pH of the water, pH of the any solution ranging from, on the basis of hydrogen ion, ranging from 0 to 14, and therefore the color of the pH starting from the dark red to the dark blue color, within this range the pH of the solution is observed. Now common ion effect affects the dissociation value, degree of dissociation. We know that any common ion effect, when any common ion is added into the dissociated ion, the precipitation or dissociation gets suppressed. Now ionization of weak electrolyte, acetic acid, suppose it is suppressed by adding the strong electrolyte sodium acetate containing acetate ion in common. For example, acetic acid dissociate into the acetate ion plus hydrogen ion. Ka is equal to minus acetate ion into concentration of hydrogen ion divided by concentration of acetic acid. Now any one of the common ion is added, the numerator value is increased, and that's why to keep the constant Ka value, the denominator is also increased, and therefore the whatever the ions are formed, they are again transfer backward reaction, and we get the concentration of acetic acid is gone increases to keep this constant. Now for example, suppose we are taking the any one of the compound here, one weak acid is taken into the solution. It is a saturated solution, and in the saturated solution if we add small amount of acid, immediately it starts to again reprecipitate out because the backward reaction takes place. In this way the degree of dissociation gets suppressed with the help of by the common ion effect. Now another effect like salt hydrolysis. Now when acid react with the base, we get the salt and water. This is the neutral reaction. Now this is for strong acid and strong base. But in case of if we use the weak acid or weak base, then what happens? Suppose salt is formed of a strong acid and weak base, slightly acidic solution is there, because whatever the weak base is there, it reacts with water initially and it gives the formation of weak base plus hydrogen ion already there, and when we add the strong acid, slightly hydrogen ion concentration is increases and further again reaction takes place, and therefore what happens? The slightly solution becomes acidic. Now when salt of weak acid and strong base is taken, then slightly what happens? Weak acid is react with water to give the formation of slightly OH ion concentration, and therefore initially the solution becomes slightly basic, and therefore if we take the solution of this, then we observe that solution becomes slightly basic in case of the strong acid, we are observing this solution becomes slightly acidic, not a neutral ion. And when salt of weak acid and weak base is observed, then it depends on the strength of Ka and strength of base Kb, the strength of acid and strength of base, which is more. In this way, the solution becomes slightly acidic or slightly basic. Such a type of effects, because of the salt hydrolysis, whether strong acid or strong base is used, or both are strong, is used. Now, in case of the buffer solution is the solution is an aqueous solution consisting of the mixture of weak acid and its conjugate base, and vice versa. Its pH changes very little when small amount of strong acid or small amount of strong base is added. Now, it resists the sudden change in the pH when we add the strong acid or strong base in the solution, and therefore buffer solutions has a certain property. It has a definite pH value, and no change in the pH value when we kept into the atmosphere, or pH value does not depends on the individual concentration but depends on the ratio of the concentration. Now, there are two types of buffer solutions, acidic buffer and basic buffer. Acidic buffer is made from the weak, it is a mixture of weak acid and its salt with a strong base like acetic acid plus sodium acetate, and the basic buffer is prepared from the weak base and its salt with the strong acid. Now, when we are thinking about the mechanism of the buffer solution, in case of the acidic buffer and basic buffer, suppose for example in case of acidic buffer, here it is a mixture of acetic acid and sodium acetate. Now, it is observed that the acetic acid and sodium acetate, they are freely randomly moving in the solution, and when acetic acid dissociates into the acetate ion plus hydrogen ion, and sodium acetate is a salt, therefore it is completely ionized into the acetate ion and sodium ion. Now, when we add the acid, now it is observed that when we add the acid, then it is observed that hydrogen from the solution react with the acetate ion to give the acetic acid, and there is no that much change takes place or decrease in the pH is observed. And when base solution is added, then it is observed that the OH ions are added in the acetic acid present in the solution. It react with OH ion to get the acetate ion. In this way, when we add the acid or base, there is a small weak acid or weak acetate ions are formed, and therefore there is no that much change takes place in the pH. In this way, buffer gives the action for acidic as acidic buffer. Now, in case of the basic buffer, instead of the ammonium hydroxide and ammonium chloride, they are mixed together, and they freely randomly these ions are moving as an ammonium ion plus OH ion plus chloride ion. These three type of ions are moving in the solution, and when we add the base acid added, then ammonium hydroxide react with hydrogen and to give the formation of hydrogen ammonium ion, and base is added, we get the ammonium hydroxide. In this way, not that much change takes place in the solution in terms of the pH. Now, in case of the acidic and basic buffer, the Henderson equation, that is pH equal to pKa plus log of concentration of acid by the divided by concentration of salt, and for pOH, pKb plus log of salt concentration of salt divided by concentration of base. Now, according to this equation, the buffer of the various pHs are prepared, and we can use these buffer solutions at a different pH. Now, buffer capacity and its preparation related to it is a number of millimoles of the strong acid or strong base required to bring about an unit change in the pH of the buffer. Now, when we observe that when acidic buffer or basic buffer, acid or base is added, the pH is slightly changed by the one pH for a lot of solution, and therefore it does not affect on the pH. Now, in case of the solubility and solubility product, maximum amount of solute dissolve in minimum amount of solvent to get the saturated solution at the definite temperature. This is the solubility, and solubility product is the product of the concentration of ions at the solubility at a particular temperature. It is this solubility and solubility product, it is used in the precipitation reaction for the qualitative analysis in case of inorganic or organic qualitative analysis. Now, in this way, the solubility and solubility product is used. Now, in case of the buffer, there are so many